Good day, viewers. In the previous video, we started the measurement of concrete fascia. I showed you guys what concrete fascia is, and we also measured the concrete work in concrete fascia. So in this video, we're going to measure the other two items that are left. So we're going to measure the formwork and reinforcement, so concrete fascia. I told you guys in previous video that the finish aspect of the concrete fascia, we're going to measure that when we get to measurement of finishes. So in today's video, I'm going to measure concrete. So we're going to measure formwork and reinforcement. Let's start with the formwork. As we all know, formwork is measured in meters square. Whenever the the particular concrete work, the height is more than 50 mm. Sorry, when the height is more than 500 mm, yes, 0.5 meter. When the height is more than 500 mm, that concrete work is the form of that concrete work will be measured in meters square. And what we have here, I'm sure that by the time we trace this part, and this part, what we have will be more than 500 mm. So I'm going to measure the form work to our concrete fascia in meters square according to BSMM 4R. In doing that, I measured the perimeter of the building in the previous video because we will need that perimeter. The form work also run through the perimeter of the building, and it will run through the edge of this particular concrete work. This part here will rest directly on the last coach, on block work, the last coach, while we have form work to this side and this other part of the concrete fascia. So what I'm going to do now is that I'm going to measure the form work to our concrete fascia with the aid of our linear tool. Since our form work we measured in meters square, we need two dimensions. We need the perimeter of the building, which is already measured, and we also need the how do I say, like the perimeter of this particular work itself, this particular concrete work itself, except this base, because the base will rest directly on the block work, on the last coach. So I'm going to measure the form work with the aid of the linear tool. Linear tool. Let's activate our linear tool. I'm going to rename this as formwork, and that will be under concrete fascia. Our formwork cover this part. So I'm coming. I want to change the color of this particular measurement, so you see what I'm measuring. Let me deactivate this and change the color. Escape. Formwork. Let's change this to red. Formwork. Okay. So the formwork will cover this part. We will not have formwork below this concrete work. I'm going to click on N. Then we have formwork to this part too. I'm going to make use of that special tool here, the arc tool. Just click and hold on A, and we have our arc measured. Sorry. Click and hold on A. Click on beginning of the arc, middle of the arc, and I don't know what something is wrong. Click and hold on A, beginning of the arc, beginning of the arc, and the end of the arc. I don't know what's wrong. Alternatively, you can also zoom in and you click at short distance. You can zoom in this way. but this will take time. I don't know what's wrong with the arc. It's not forming the right arc. Okay, we have it measured. This part and this part. So with this, we're done with the perimeter of the concrete fascia itself. So I want to multiply the value of the perimeter of the concrete fascia by that of the building to get the value of the formwork that is required. Take off summary, concrete fascia. Okay, these are our formwork. The perimeter of the building is 68.74. Advance, take off, multiply by 68.74. And don't forget to change this unit from meter to meter square or square meter. Then click on OK. So we have our formwork measured. The last item of work we're going to measure is the reinforcement. The reinforcement is in two parts. We have the main bar and the stirrup. Like I said the other time, this part is like the roof beam, while this is the concrete fascia. So we have YMM in YM. We have 12 Y. We have Y12 in the roof beam part of the concrete fascia, and we have Y8 in the concrete fascia itself. But the whole thing is the same as that concrete fascia. You can almost see this thing here. The description here is roof beam, not concrete fascia. But nevertheless, let's quickly measure um, the reinforcement. In measuring the main bar, the 12 mm bar, what we want to do is just take note of the numbers of 12 mm and we'll multiply that by the perimeter, building perimeter. Because if we have four numbers here, the way we have it here, so that means the length of this particular bar here will be this particular perimeter times 4. That will give us the total value of our 12 mm. And that same perimeter times the numbers of Y8 here will give us the total length of the Y8 that is required. I'm going to duplicate this perimeter. How to make use of that? Done. Paste. Yes. Okay. I'll rename this now as my Y12 reinforcement. This is Y12 mm. And I'll rename this as Y8. Y8 mm. For my Y12 now, I have 4 of them here. 1, 2, 3, 4. You can make use of your count too. Y12. Numbers of Y12. Numbers of Y12 mm. 1, 2, 3, 4. Escape to have 4. That means I'm going to multiply what we have here, this particular value, by 4. That will give us the value of the reinforcement in meter. So this will be times 4. To add value of our reinforcement in meter, we can also change this from meter to kg and from kg to ton. If we want to change this particular length of reinforcement to, let's say, take for example, to kg, that means we'll multiply what we have here by the conversion factor for 12 mm. Then after that, if you want to convert that value from kg to ton, we'll divide whatever we have by 1000. So we can program this in the sense that we have our final value in ton or kg, as the case may be. I can also leave it in meter. So that's why it's very important that you take note of the units. So if since this is in meter, after exporting the measurement, whenever you want to make use of that particular value, the what do you call the unit there will tell you what to do. So that's why it's very important that you make use of the right unit. This is meter. So whenever I want to use this particular measurement now, the units will remind me that I have to convert this to kg to ton, as the case may be. Let's count the numbers of y8 to have. Y8 mm. 1, 2, 3, 4, 5, 6, 7. So we have 7 of that. Remember, I'm going to multiply this by 7 times 7. That will give me the total length of y8 that is required. I also wanted to take note of something. The standard length of reinforcement is 12 mm. So that means, sorry, it's 12 meters. So that means we have a lot of reinforcement ties together to make up the reinforcement that is required. And in joining reinforcement together, there's something called lap. There's something called lap. So the two reinforcements, you have to like form a lap where you use binding wire to join them together. So that means at the end of the day, we need like extra length of reinforcement for both our 12 mm and 8 mm. And we can measure that accurately. The only thing I would suggest that we'll do is that we'll add particular percent to what we have here. And if you want to like measure it accurately too, you can also make it of a calculator. We divide this by 12. Whatever we have, give us the numbers of value that will add to it as a lap. You can do it this way. You can make it on my calculator. Okay. On my calculator here. The total length of 12 mm here is 273.88, and the standard length of a reinforcement is 12 meters divided by 12. I know it's possible that what we have in market these days is not for 12. Let me make use of 10 meters instead. Okay, so that means we'll have about 27, or let me say 28 laps. We have about 28 laps. And if you want to cater for the extra length of reinforcement that will be required to form that lap, I think what we did in our previous video, we make use of, was it 75 also? And for stirrup, usually make use of 100. Is it 100 or 150? 0.15. So if I should multiply what I have here, 28, 28 times 0. Let me use 0.2 instead. 28 times 0.2. 28 times 0.2. That means I'll have additional 6 meters or so as lap. And the lap will be times 2. Will it be times 2? Yes. Okay, no, it will be 1. 1 lap for each reinforcement. So we'll have additional 5.6, or approximately 6 mm, or sorry, 6 meters length of reinforcement. Let's quickly add that to what we have here. Just want to show you guys how to go about adding that lap to it. Plus 6 meters. Okay, so we have our lap added already. And for this, you can also do it this way. I don't know, depending on how you want it. You can multiply this. Let's say you can also multiply the whole thing by particular percent. Let's add 25% to what we have here. So this will be times 1.25. So that will cater for the lap that way. So whichever way, you can add your lap the way you want. Okay. We have 2 reinforcements left to be measured here. The link joining the roof beam to the concrete fascia, and the link in the roof beam itself. So this is our perimeter. Okay, no problem. We will need the total length or the perimeter of the building. We need that to calculate the numbers of links that is required. But before then, let's measure the length of the link. I'm going to measure that with the aid of my linear tool. I'm going to measure my linear tool, and this particular item is link. And I believe the diameter of the link, although it's not stated here, is 8 mm. 8 mm. 8 mm link in 8 mm link. Okay, and that will be under concrete fissure. So the link in the distance itself, in the roof beam itself, will be from this point down this way. Let me switch off this snap tool. Okay, next, then the link in connecting the roof beam and the concrete fissure, it goes this way. Escape. So that's the total length of the link. And the next step now is to get the numbers of link that is required. In doing that, we need the perimeter of the building. Change that particular measurement to something else. Let's check the perimeter of the building from the other plan. This first plan. I think we measured something here. Okay. So the perimeter of the building here is the perimeter of the building is 68.47. The perimeter of the building is 68.47, and our spacing, let's make use of, we can either use 150 or 200 mm. This spacing is not stated actually in the drawing, it's not stated. Let's make use of 150. We're going to divide this by 0.15, or we divide this by 0.2. So let's divide it by 0.2. 0.2. So that means we'll have 342, or approximately 343 numbers of link in our concrete fissure. 343. Now let's go back to our takeoff summary, and we're going to multiply the numbers of our link here by 343. 343 times 343. Then you click on OK. So with this, we have our link measured in meter. Let me delete this. So with this, we've come to the end of measurement of concrete fissure. In the next video, we'll move to the next item to measure. I think the next item here will be finish. So measure the different type of finish: wall finish, floor finish, ceiling finish, painting and plastering, and all of that. See you in the next video. Thanks for watching.